Hi students, welcome back to some more geography lessons with Mrs. T. In this chapter, which is chapter 4, we're going to look at temperature and insolation within the Earth's atmosphere. So we're still talking about the Earth's atmosphere, and you will need your information, your knowledge that you gained from previous lessons about the composition of the Earth's atmosphere, the layers of the atmosphere, the ozone layer that we've discussed, the chemical makeup of the air in our atmosphere, and we're going to add in these lessons, we're going to add energy, incoming radiation, incoming solar energy, and how it affects and interacts with the atmosphere. And we're also going to bring in the second half of chapter 4, which we will do in another lesson folder. The second half of chapter 4, we're going to look at how incoming solar radiation is affected or affects land and water masses in different ways, how it affects wind and this kind of thing. We'll do a little bit about the wind in this first half of the chapter, primarily with convection and advection of air in the atmosphere in cells as it rises and lowers, and how the temperature variations that happen from seasons to the year and times of day affect rain and those kinds of climatic trends. Okay, so we're looking at temperature and motion within the atmosphere. And the topics are going to range from the energy that comes from the sun and the heat that comes from the sun, and particularly solar radiation, although any kind of radiation decay, radioactive decay that happens within the earth emits radiation, emits energy from the earth itself. But for the most part, the energy that we are going to investigate, how it affects our climate, how it affects weather patterns, how it affects wind, how it affects the temperature at the surface and at various layers of the atmosphere, comes from the sun. And so there's going to be a lot of information in this chapter about the type of light, the wavelength of the shortwave radiation versus long wave radiation, and also the light spectrum, the visible light spectrum, the rainbows. Roy G. Biv, you might have learned that acronym back in, I don't know, 5th grade or something, for the different colors of the rainbow. Those are considered visible light, and the reason we can see or perceive these different colors with our eyes is because of the reflectivity that these objects have in terms of the visible light spectrum that we perceive down here in the troposphere where we exist. So we will be investigating all of that also. Okay, and one of the things that we need to talk about in this chapter, like we've talked about in previous chapters, the difference between miles or knots or kilometers, and the conversion of those different measurements for distance in that example. We have a variety of temperature scales that we use in science and in physical geography. And the two temperature scales that you will see in physical geography are the Fahrenheit, degrees Fahrenheit. The little circle is a degree symbol, and the F stands for Fahrenheit. This is the most common temperature range that we grow up learning about in the United States. 32 degrees Fahrenheit is the freezing point, and 212 degrees Fahrenheit is the point at which water boils. Celsius is another very commonly used temperature measurement system throughout the world, and 32 Fahrenheit and 0 degrees Celsius are equal to each other, and 212 Fahrenheit compared to 100 degrees Celsius are equal to each other. And so there's a conversion formula that we can use to understand or to get from one measurement to the next. And another type of measurement system that is used very commonly in science is the Kelvin scale. We're not going to focus on kelvins in our physical geography class because we just don't use them in this field. And so Kelvin is a scale that's very useful in other aspects of science. It doesn't have any negative numbers. There are negative numbers, like you can have 0 degrees Fahrenheit or -1, -2. I remember a few years ago there was like a 2 or 3 nights in a row in February here in Arkansas where it was like -9 or some ungodly number like that. And so in Celsius and also Fahrenheit, you can end up with negative temperatures. Kelvin eliminates all that. There are no negative numbers, but we're not going to spend too much time talking about Kelvin because we don't use it in physical geography, climatology, meteorology, those kinds of fields that we're studying in this class together. Okay, so you're going to have some curated videos to watch that give you animations, a visual context of how solar radiation happens, how absorption happens, how different types of convective cells occur because of what kind of radiation is coming in, deflecting or being absorbed into the earth from the sun's rays, the electromagnetic spectrum. And so one of the things that we're going to investigate, I need to, not look away from the camera when I speak. One of the things that we are going to investigate in this chapter are the questions about why do temperatures change, not only from place to place, but seasons of the year, because of course the earth rotates and wobbles, right? And so based on that wobble, we have different seasons of the year. We've already learned that. And the angle of incidence of the sun's rays change based on that wobble position. And so from one season to the next, we also have changes in temperature. We have changes in the climate periodically, cyclically. We have those changes. And so also from place to place, even, of course, we know about latitude and longitude, and we know how to measure these things, these coordinates on a map, but even from, say, the seashore to just inland, like 10 miles, you haven't changed your latitude very much when you are on Pensacola Beach and you go into the University of Pensacola, for instance, of the University of West Florida, that is, about 13 miles inland from the beach. And so you can notice palpably the difference in temperature, the difference in airflow, the wind is significantly different at the edge of the water. And so the answers to these questions of why does this happen, we're going to get some of those answers from this chapter. And also, we have discussed in previous lessons that here at the surface of the earth, we usually have a higher heat, a palpable, a heat that we can feel. We usually have a higher temperature at the surface of the earth, and at the same time, you can go to the mountains, and because the altitude is different, it's colder, and condensation has happened in the form of snow. And so even throughout the summertime, in some places where you have high enough altitude, you can have a snow-capped mountain 12 months out of the year because of the altitude. And so the reasons for these kinds of phenomenon are provided. Some of the reasons are provided in this chapter, and we're going to be investigating them. Okay, and so yes, two of the topics that we will focus on in the next couple of videos are insolation. How do we receive energy from the sun? How do we absorb it is also another topic. And also outgoing energy, because the earth emits radiation too. We don't just absorb everything from the sun. We have different parts of our atmosphere, different surfaces around the world that have a reflectivity. They have the ability to emit radiation rather than absorb it and take in latent heat and latent energy from it. And so we will be investigating all of those things in these lessons. Please make sure that you slowly go back over this if you haven't already been doing it, and take notes and make bullet points, these bullet points that I have on the board here. Make sure that you take them down in your notes, and include extra information as you're going through your reading assignment about energy and heat, what solar radiation is, how the earth has things that radiate energy from it, but not nearly as much as we get from the sun. Other stars in the universe, of course, emit radiation also, but they're just too far away from us to affect the earth's atmosphere. And so take those bits of information and include them in your notes so that you'll have them at your fingertips to do your reflection journals, to do your quizzes, and then also your unit assignment that's coming up at the end of this module. Please text me with questions and look in our folder for the next set of videos.